So far in the past couple of sections, we've been looking at these solids of revolution, and we've been looking at computing their volumes through two different methods that we have. We have the washer method and we have the shell method. So we also talked about the disk method a little bit, but remember that the disk method is simply a special case of this washer method. It's a special case where the inner radius of the washer simply has, it's equal to 0. There is no inner radius. So we're really only concerned here between the differences between the washer method and the shell method. So let's think a little bit about what's going on with the washer method. In order to do the washer method, we had this setup where we were looking at maybe some functions here, and we were looking at the area between them, and we were looking at rotating this about some axis. And with the washer method, what we did was we took these either these vertical line segments and we rotated them about the x-axis. So taking a vertical line segment there and rotating it about the axis gives me exactly some kind of washer. The other way that we could have done the washer method was if we were looking at, let's see, so if we instead had some kind of region here where we were taking horizontal line segments, and this time we were rotating them about the y-axis. So here we were taking this kind of blue function here and forming the outer radius, and this green function forms the inner radius, at least where I've drawn kind of that red circle. And then these horizontal line segments form the inside and the outside of the washer. Let's see. So that was kind of the depiction of our washer method. Notice that kind of what's going on here when we take one of these vertical line segments and we rotate it about the x-axis. This means that we're integrating with respect to x when we're looking at these vertical segments, because we're taking these vertical segments and we're seeing how they change as I move from left to right. In other words, as I vary x. So this here is this case that we're looking at with the washer method has integrating with respect to x, and it also has rotating about the x-axis. Likewise, in the second case, here we're integrating with respect to y because we're looking at these horizontal line segments as I move up and down. That means, so we're integrating with respect to y, and we're also revolving about the y-axis here. So the primary feature of the washer method is that the variable of integration is equal to the axis of rotation. When I'm integrating with respect to x and revolving about the x-axis, that's a washer method problem. When I'm integrating with respect to y and revolving about the y-axis, that's a washer method problem. Now the other method that we are looking at is the shell method, and you can guess kind of how it's going to be opposite here. If I were to use the shell method on maybe revolution about the x-axis, what I would be looking at is I would have my blue and my green function here, and I would be taking these horizontal lines, and in order to form a shell, I take that horizontal line and I revolve it about the x-axis. That forms this situation where on maybe the right-hand side of my shell, I have my blue disk, and on the left-hand side, I have the green disk. Ooh, that's a rough drawing. And then the purple horizontal lines correspond to kind of the width of this band that I'm drawing here. Similarly, in the rotation about the y-axis case, I have, again, a couple of functions. I have the area between them as vertical lines here, so I'm integrating with respect to x, and I'm taking these vertical line segments and I'm rotating them about the x-axis to form some kind of band this way, or some kind of shell, where maybe the top is given by green and the bottom is given by blue. And those vertical line segments give me kind of these vertical pieces here on the boundary of that shell. So here we can see that in this first case, I'm integrating with respect to y because I'm looking at these horizontal segments as y changes. And I'm integrating, or I'm revolving about the x-axis. In the second case, I am integrating with respect to x because I'm changing these vertical segments with x, but I'm revolving about the y-axis. So in the shell method, we're looking at where the variable of integration is not equal to the axis of rotation. So with these primary differences, that sort of begs the question of how do I decide which one to use? Kind of given that I know now the difference between the two, which one is better in which sort of cases? And I want to first emphasize that there's no absolute rule for doing this. Sometimes you just have to try both and see which one works best. But there are some general guidelines that can be really helpful. So the first question that I like to ask is which variable would I integrate with respect to if I were finding the area of R? So R is some region in the plane, and I might think first which variable would I use if I were just finding that area of R? We've talked a little bit about this question already in the context of finding the area of R. It's really nice to, for instance, use the integrate with respect to x if, for instance, your region has a single curve for the lower bound and a single curve for the upper bound. It's nice to integrate with respect to y if you have a single curve for your left bound and a single curve for your right bound. So that's sort of maybe the first question that I would want to answer. The second question is, which axis is R being revolved about? This question is really easy to answer because the problem will tell you which axis R is being revolved about. So once we've answered these two questions, question 3 is going to be, are the answers to 1 and 2 the same? If these answers are the same, that is going to indicate to me that I want to use the washer method, because the washer method tells me that the variable of integration is the axis of rotation. And that's what I've answered in these first two questions. 1 is asking about the variable of integration, 2 is asking about the axis of rotation. So if yes, I want to use the washer method. If no, I want to use the shell method. Once I've done this, and I've sort of answered the question of which method I want to use, we actually have to think about moving on here. So step 4 might be something like set up the integral. Once we've set up the integral, we want to know, well, can we integrate? Because the answer is not always going to be yes, as we'll see later on. So the sort of follow-up to this is, if we can't integrate, try the other method. Might be a little bit messier, but at least maybe we'll have a shot at integrating this new function that we're going to get. All right, so that's all for this first video. In the remainder of this section, we'll take a look at sort of using this decision-making process in order to see which method is better, and we'll even do a little bit of comparing and contrasting between these two different methods.